People want to learn things practically. They don't want to sit in a hotel. They want to see things actually. And we've had a series of these build tours. We had one to Kericho earlier on in the year. We had one about 2 weeks ago to Tatu, and even that one was oversubscribed. And then this one, which is a build talk meeting a build tour. So we're very, very excited, and we're excited to learn this evening the making of a skyscraper, and also some conversations about excavations and what it makes for a skyscraper to go up, what you need to do underground. So very exciting sessions that line up for you, and we are really happy with how the members have engaged. And if you're not a member, please make a point of joining the AK if you qualify. I'm very happy to see the students in the room. Please, can we see your hands? Thank you so much. We hear you. You always want free events. We have listened to you. I'm sure some of you have walked from ADD, and we're very happy to see you. So asanteni sana. And without much further ado, I think I'll just hand over and to the engineer structure. But before we do that, please, if you took a photo up on the rooftop, pull out your phone, tweet it using the hashtag AKBuildTalk. AKBuildTalk. If you took a selfie, please do. If you took a selfie with me, tag me as well. So asanteni sana, and it's going to be a rich evening. Please don't go even if you're standing. You're burning some calories. So just keep at it. There's a lot to learn. Yeah? No pain, no gain. So karibuni sana, and we look forward to an engaging evening. Thank you.
My name is Ashpal Sabharwal. I am from Talent Carpets, and on behalf of the Talent Carpet team, before I start, I just want to take a few minutes to thank the AAK team, as well as Britam Towers. Britam Towers, because they put their trust in us to help so that Talent Carpet can supply some of the things that you see, towels and some of the sanitary that you're seeing around yourself. AAK for allowing us to come here to this forum, the Build Talk, and talk to you and engage. I came up here initially to talk about a presentation, a product called Tactile, but I don't think I'll use a presentation because I was told to keep it short. So Tactile is stone-coated roofing solutions. This is a product that has been locally manufactured by Talent Carpet. It is the first of its kind to be manufactured here in Kenya when we started. After that, then we had other players who started manufacturing it. But we were the first of our kind to start manufacturing stone-coated steel roofing tile. What makes it different from any other stone-coated tile that you see? Why am I talking about it? Why do I want you to know about it? One is that it's a Kenyan product. So unlike every other product that you see, this is made in Kenya, and support the local manufacturer. Two is that we make this product with a lot of quality in mind, quality and empathy. Empathy being that a lot of people in the market have been cheated. So we try to ensure that our quality is of the highest standards. So we have our factory in Athi River together with the Top Tank factory. As most of you may know, Top Tank is one of the products that is done by Talent Carpet. Apart from Top Tank, we have Top Pipe, Kalakim. Kalakim is a tile and adhesive grout. So Tactile is one of the members to join that club for locally manufactured brands by Talent Carpet. So we have 4 profiles. Unfortunately, you won't be able to see them, but 4 profiles ranging from 18 different colors. So that's what makes us different as well. We have 18 different colors that you can choose from for your roofing. Aesthetically, this gives us a very good edge because we are one of the very few that gives you this wide range of color choice, from 18 to 19 and sometimes up to 24, depending on the type of profile you choose. So we have every color imaginable, from the reds to the greens to the blacks. We have done a few, I'd say, very monumental projects. One of them being Thika Greens. Thika Greens, we did the main clubhouse. We were able to successfully supply the tiles for the main clubhouse, as well as the Thika Green housing development that's around it. One of the biggest residentials we've done so far is the Riverine in Kitten, Gala. It's around 300 units.
So we were able to supply those tiles to the clients. Sorry. So with that being said, because we have our factory here in Nairobi, we are able to supply large amounts of tiles to clients. So one of the issues that clients will not face is that we don't have enough stock. We're waiting for containers to come in and all that. Usually production is done within 3 to 4 days from the date of the order. So if you order, like say, even 6,000 tiles, that's if you're doing a unit that's like 300 units or houses, you can get that within a week's time. We'll do your 6,000 pieces comfortably at our factory in North River without having any issues or whatnot, without compromising the integrity of the quality and the integrity of the product. Tactile, the factory was the first factory we opened up here in North River, Kenya. The second factory we've opened up in Bahrain, Middle East, so that we can at least cater to the North African market. So, yeah, with that being said, there's not much to talk about tactile because the presentation is not here. But for the architects, the consultants, and anyone who's willing to get into the construction industry for residential, it's something that I hope you would consider. It has a lot of benefits, which is technical, so we won't get into that, but it does have a lot of benefits that in the long run you will be very happy about. One thing I can say is that we offer 50 years warranty on these tiles. So for some of us, it will outlive us, which is a good thing, or I think. But yes, 50 years is quite good, especially for a local manufacturer, for us to proudly say that this is what we're putting on the table. 50 years for your roofing, for your house, to keep it sheltered. 50 years is not too bad. So with that being said, I'd like to again once more thank AAK and Britam Towers, and hand the floor over to Mr. Ndung'u.
Patrick Wanjohi from IOTA Engineering and Construction, and our former name, as many of you may have known it, was IOTA Excavations and Foundations. Today, I like us to quickly move into today I like us to quickly move into the subject of the day, which has to do with the deep excavations and the issues involved there like foundations and the other issues of interest, like collateral support. Let's start quickly and ask ourselves, why do the excavations? And basically, it's about meeting the rising demands in the construction industry. Like, land is getting much more expensive every day, so we have to think about the utilization of the space that we have. But like we said, the cost of land is rising, and we have to get the best utilization of the land. Parking requirement, because now everybody needs a car, and that has also to be accommodated in a good cases where we are today, without forgetting the legal requirements on the build-plot ratio, geotechnical considerations, how is the ground like, and of course sometimes the designs and the clients may require certain things for things to be okay. So then we have to dig. And every day now, because of that item, you can see like here, we are getting closer to the neighbor, irrespective of the fact that we are now in the reconstruction moment where we pulling down some buildings and putting new ones. We still feel we need to go to the neighbor's boundary line, or our boundary line. And this is typical in every other place, even where clients are owners of the next building. They just want to move very close to the other one. When we think about the cost of land today, I did simple math. If you have 1 acre costing 500 million, 1 square meter is 125,000 Kenya shillings. That's a lot of value. And now, let's see the challenges in deep excavation especially, and those deep foundations that we talk about. I would first of all mention on the environmental factors that are in this particular activity. And normally they are ignored because when the designs are done and the activity is happening in a secluded place, nobody knows when the materials have left that site, where they go. It's an important question that we need to ask ourselves, and most primary, because it's also in the ecosystem that we are in. And when we talk about a good environment, it's not just this particular spot where we are. I find this a big topic that we cannot exhaust, even given a day. So we need a big thought about the environment when it comes to removal of material from one place to the other, because it is never destroyed, it is just relocated from one place to the other. And this maybe everybody needs to think about it for us to have a good environment now and into the future. And maybe also to allow enough time during the excavation so that people have different use of the material so that it doesn't actually go to clog the areas that we would put what we don't need to use again. Yeah. And the other challenges that we are always seeing is when we have very close structures that were previously built, and now we also want to go down below their foundations. This is a big item, and people are worried, what is going to happen to my structure? What is going to happen to this structure that doesn't belong to me? Will there be a legal issue coming up? So, and it is a big worry for everybody, and people are thinking hard about it. But the solutions are there, so we're gonna look at the solutions also. The other nominal challenges that we have, or we have to come across during deep foundations development are things like the material hardness. Okay, no problem. So, sorry. So sometimes we find the materials are too hard, and we don't know how to deal with the material, and that means more cost. So sometimes we have to think about what equipment to employ to make it cheap. It's never very cheap, but somehow it's well done. And we also think about corruption, which is also a big worry because we are taking care of improving life of the people. So what about when we lose the life? It's a big worry, we have to think about it. And sometimes on that item, cost is irrelevant. Yeah. And we also have various kind of other challenges like SAD, learning SAD, if the SAD has water, swelling crates, whether they are on the sides or they are in the bottom. And we also have other failures like rockslide and rockfall. And also groundwater. And not to forget, it's not just groundwater, it's also inrush water. Yeah. And we also have other challenges that are inherent with depth. Sometimes the excavations will only collapse a small section and can fall in to the excavation pit and injure people. And also other objects. If you forgot something at the top there, and now you are 12, 15, 30 meters deep, this object, however small it is, the impact is so big. So sometimes we also have to think from the top, what do I do? Can I clear? And exposure to underground services, sometimes also in Kenya is not so much, but at the top level is there. It's also a little challenge. Sometimes you come across high tensile cables that can be of great injury. You know, also for equipment that is in the excavation sites, sometimes it's big equipment, not easy to turn, heavy equipment, and may cause little accidents. Sometimes also people who have height phobia may not even be able to operate the equipment well, even as they are good drivers and good operators out there. Water inrush again, and with the confined spaces, this is also another big challenge. Safe access for people and mobile equipment. You know, normally as you go deep, the chances of having a wide road reduce, and it means there must be inherent interaction of equipment and the people. So a lot of care must be taken. What should be done there? This is another big issue. Water inrush, this we have found it many times in town, especially when it has been done during the rainy season. It's a big problem. Other problems like this, when you cannot be able to control when the water came in, and when you dug around and the trees can fall on cars, like we have seen in many instances in this town. And collapse like what we just mentioned, and it is catastrophic. This one happened in Kenya and, killed a number of people. That was a little sad. Yeah, and this is also happening elsewhere in the world. Just picked a photo. Okay, let's see the solutions to these numerous problems that we have mentioned. I hope this is going to be useful now and into the future. So we could also, we could have the solutions of lateral support by buttering, say, cut the sides when they are inclined. And this is scientific, those who know. We have specific angles for different material to make sure that the material doesn't slide down. Different sides, some material require only a small slope, other material require a big slope. Yeah. Yes, and properly engineered systems like pile system, soja piles, and the soja pile may be combined with a few other things to take care of loose material or likelihood of material to slide down, timber raggings like that, and shotcrete, brown cement, short cement, shotcrete from the word shoot, and concrete. And this is also reinforced, structural reinforced shotcrete, and it's very good for most of the surfaces that are unstable. And this is a soja pile, a combination of soja piles, reinforced shotcrete, and soil nails for deep excavations. This is in Westerns, someplace in Westerns, and that is the end product, or near the end product. And this is also can also be used as permanent structure. Like this was used as permanent structure. No need to construct a retaining wall. You could see that blue item for taking off the water to allow the construction to happen, to take water, the drainage system. Yes, that's the end product. Quite good. And soil nails and reinforced shotcrete is another solution to take care of the vertical walls, especially when they are really vertical. So, yeah, that very effective for that purpose. Yeah, and some of the shotcrete and soil nails, depending on the depth, 3 meter, 15 meter, 20 meter deep, can be used even on very deep sections like this one, where you have allowance to go as far as you want. This was, I think, 15 meters, if I'm not wrong, and it has worked, and it is still standing for 2 years, despite the fact that construction has not happened. Yes, so a combination of soil nails and reinforced shotcrete, and that structure is a retro high structure, not just what you can see. And that is landmark building, which is also 20-something floors, and a number of soil nails there, and log bolts there, and soil nails. Shotcrete has actually done well. Now the construction there is up, and this is just an illustration of the systems that we have just showed there on the soil nails, schematics of the same. And of course, a bit of engineering has to be done to ensure that you have the right dimensions and the right specifications for this one. Another system that is also waterproof. I could have water on one side and no water on the other side is sheet pile. A sheet pile also requires a bit of design, and sometimes it has to be reinforced with some whaler beams and this kind of thing, and we need specialized equipment to drive in sheet pile. Also, simpler equipment are there, And this equipment, most of the equipment that we are mentioning here are available here in Kenya today. So the situation is improving every day. It's not like 10 years before when we didn't have the equipment. Yeah, a typical case of sheet pile. And this is especially good when you are doing bridges on the river banks and seashore. Yeah. Yeah, and if you also build on the riparian, yes. Okay, and the walls can be even more complicated, but the same thing combined now, you can have different piles, you can see, some of them reinforced, others not reinforced, different kind of reinforcement, different spacing, and we can give them different sorts of names, but they are basically a pile system for the same. And sometimes also the piles can be supported by anchors to give them lateral strength. And rock bolting, this is when you have really hard material, but it has fractures that may cause movement and cause injury of people, and sometimes also can be catastrophic because the neighbor's property can be in your pit. Yes, and it's also a bit of scientific activity there, and depending on the fracture index, the bolts can be very deep and the diameters can be big. The bolts can be of small diameters, 12 millimeter up to 32 millimeter, 45 millimeter. We've seen such large bolts. They can be short as 2 meters, as deep as 16 meters we have done here in Kenya. Yeah, there. And the combination of the same things that we said. This is foundation on piles. Foundation on piles. That is actually 30 meter. Is this the middle section. And it's surprising the way nature can be. The material was very hard, but when we arrived here, there was need for piling. And $1 billion shillings was sunk in the piles. Yes. It's maybe short 10,000 short of $1 billion. 1 hectare coverage. Yeah. No? Yes, 2.5 acre. Yes, 1 hectare. Yes. So the other thing as a solution to the challenges of excavation, and this is most basic, is the scientific finding out of the geological strata. So we call it geotechnical investigations, and this is very, very important to be able to control the costs, the ultimate cost of the construction at the foundation level, and even to be able to predict it right, so that we have good planning by the owners of the money and the owners of the construction. And the purposes of geotechnical investigations are basically classification of materials for that part of costing, and what we call profiling. I will just show that profiling in a short moment. Of course, determination of Okay, no problem, thank you. So if you see, material can change fast. You had very good material, like this is material that was very good, maybe up to 80 MPa, and all of a sudden, around the whole site, you arrive at material that cannot even meet 10 MPa requirement to support even a small structure. Yet you had material that was very hard at the top. So this is supposed to be determined by good geotechnical investigation, and also to inform the construction beforehand what to do with this kind of situation. What we mean by profiling is like this. The ground is not even. Some places are deeper than others. So when you do just a borehole at one point, you might not be able to relate at what depth is this material the same in each of the boreholes. So there is need to do a survey, the topographical survey, and relate that information with the geotechnical information regarding the depth, so that you are able to come up with something that the engineers can depend on. You know, you end up with a situation that informs you, on this side I have hard material, somewhere in the middle. So what best measures can I do? This is very, very important, like we said again, in the cost control. So one case here that we just developed, we could see a site of this nature. It is not unusual to have it like we just shown elsewhere. You might see that one side you have good material to support your construction. Other areas you don't have good material and you really don't want to go deep. Like we said, the other challenges of excavation can be overwhelming. So you can make a plan beforehand what to do. Decide I will use my normal pads. In the center, I will use my piled foundations to support the structure. And some of these things need to be seen before excavation, because the excavation, some of the solutions that you need will be provided by monsters like this one. 70-ton monster cannot be put in a deep hole and you don't know how to remove it. So sometimes you might have to do the drilling from the top, remove the machine, and then that part, the drilling and the installation of the pile from the top, and that part now you can do when you have opened up, because that needs a much lighter equipment and the ordinary construction equipment that we are using all over. So good planning, guided by geotechnical and topographical investigations is good for construction, and especially when it has to be deep and especially when it has to be tall. The skyscrapers like where we are, I'm sure the engineers did a lot of work even where we are. Yeah. So, and this, I like just to make a quick comment also. Now, it looks easy when presented. But it is not easy, and this makes me think that these kind of subjects now need to be taken to the roots of our profession, being in the school, so that we are able to have an interaction of the industry and the developments that we are going to be having now onwards. And maybe probably to ask AAK to listen to our universities so that we have much more quality graduates who understand more, who appreciate more, who can save the industry much more. And not to forget that these are not the only challenges, excavations. We have seen some green mamba do something and almost get injured. There is a good way of doing it. It's about understanding it. It's about understanding the equipment. Everything boils down here to equipment, availability of equipment, and not just the equipment, also the expertise to be able to do it safely, because we are saying construction is all about improving the quality of our life. So when we lose a life, then we have lost the whole point. So basically, I would think I let AAK deal with that. And where we can as individuals, we also do. Thank you so much.
My name is Budi Architect. I'm wondering, in the process of procurement of the contract, at what stage are you engaged? Do you fall part of the main contract, or is it a subcontract? Because sometimes I can see some of these things are not seen at the design stage. So when are you engaged?
Hello, my name is Mwendwa Kiko. I wanted to ask about about the Pinnacle project. You showed us how you had a layer of very hard material on which I guess the surrounding buildings are sitting, and then under that you have the very soft material that they now have to do piling on. I wanted to ask why during the site investigation stage that wasn't discovered. Like what was the problem? Is it that they didn't go deep enough? Is it that the soft material wasn't present everywhere? Yeah.
I start with the question, with the comment from our lecturer, and I say, the industry is ready for you. Some of us are ready to spend some money to help the students to come out with more. And I must also say that a few days ago, I was excited when I was invited at Kimathi University, and I found they have now a good model that may work for the industry, and maybe we all need to copy in the other universities. They are making a science and technology park that will house manufacturing plants within the university. And they have set aside 177 acres for development of that kind of arrangement. And I want to believe most of the investors are willing, because the student fraternity is what the persons we are going to engage in the next few years. They are almost ripe. So most of us are ready to help there. And the question by my brother Budia, I think it's about the geotechnical investigations and also information from the design level and some estimate of the cost and the time required. I have seen us being engaged ahead of even the designs being finished for us to be able to do something ahead of detailing and the final approvals here, there, and detailing can take a lot of time. So we have severally been engaged as the only contractors on site to do everything that needs to be done until such a moment when construction can start. So just to answer you again. And for my brother, sorry for that confusion. It was not the same site. There were two different sites. But they are actually, both of them are within Upper Hill. We're trying to show how rapidly material can change within half a kilometer radius. All that is happening within half a kilometer radius. I'm certainly sure the geotechnical situation of this structure where we are sitting today is not the same as Pinnacle, which is not very far from here, only maybe 200-300 meters. And the other site is in this direction, KWFT head office, the construction going on there. It's not very far. But to answer you, that had been seen to a good extent. But in a scenario that is so, a lot of consultation is required, because you will ask yourself many questions. Even I have to do piles through the hard rock. How do I penetrate to get to the bottom there? So that was a hard nut to crack for all of us, including the engineering team there and the architect. But finally now the construction, I'm told the construction is at the 10th floor. That was only 2016. Yeah, thank you.
Good evening to you all. Thank you. Once again, I'm Charles Ndung'u from Triad, and I think on behalf of the project team at Britam Tower, our client is not here with us. So on behalf of the project team, I invite you formally to Britam, and feel most welcome. So I'll try and go fairly quickly, perhaps do this in 15 minutes. So please bear with me if I rush. Let me first start by saying that a project like this cannot be done without a team. So this has been a team effort between a lot of team players, ranging from contractors, consultants, and I know we have some of the consultants here with us today. I know we have Howard Humphreys, I saw, who are the engineers. Atkins, I think they are called these days, Atkins Global, Edward and Pauline, who are the structural engineers. We also have two architects from our office, Luta, Stephen Luta and Iqbal Singh. Iqbal was the architect and Luta has joined him a bit later. But that said, the team was large. As we've listed there, we are the consultants who are Triad architects, working with a company in South Africa called GAP, who we are associated with. Quantity surveyors were Back and Barton. We had engineers from the UK called BDSP Chapman, who are doing the services engineering, and also the fire studies and facade engineering. We had Maiteri and Associates, local engineers, Howard Humphreys I've mentioned. We also had a signage designer. The signage you see, the pylon at the beginning there, out there, and the signage you see up to even the ducts, and the parking silo were done by ARC. And we also had environmental consultant called Awemark. On the contractor side, the main contractor was Laxman Bay, who we settled on after, what I'd say was quite a extensive, review and, of the tenders that we received. We had quite a competitive tender. At the end of the day, we remained with two contractors in the ring, Laxman Bay and a Chinese contractor. But after visiting, even going into China to see, the Chinese work, it was deemed that Laxman Bay would achieve the best quality of the contractors who are here. So we selected Laxman Bay, and I think they did not let us down. And then we had a battery of for over 14 subcontractors, the key ones, plumbing and drainage, volcanic, plumbers, Meta Electricals. This building is heavy in services. So there was a lot of work for Meta Electricals. Schindler did the lifts. And then we had others doing the various other. I'll just mention one more, Prime Aluminium did the facade in conjunction with a company in Dubai called Al Ghurair. One of the key aspects of this project was the facade. And one of the critical analyses that was being done on the bid was the ability of the facade contractor, and Prime in association with Al Ghurair convinced us they can do it. And then we had others, up to even Falcon Signs, who did the signage. Now, that's an image taken from the park of Britam, of the Nairobi landscape, principally, Upper Hill. And the arrow at the top there shows the top of Britam Tower, which is actually the top of the spire. I've been asked, and I was asked today by Madam President, whether, which is the tallest building in Nairobi. I was hesitant to answer, but I think that picture probably gives you a good guess or answer. You see Britam Tower there, you see UAP Tower, and there are a few others. So probably for another few months, Britam, we can say it's the tallest building in the country. Now, Britam is this building was developed as a commercial investment. I know many people, when they hear Britam, they think this is a Britam headquarters, but it is actually not Britam headquarters. Some of the Britam staff are going to be housed here, and because of that, the address may, it may become to be known as their head office. The actual head office is down the road, Britax Center. So this actually is an investment project. Britam Life Insurance Company is the largest life insurance company in the country and in the region. And they hold a lot of substantial funds. And, a lot of these funds have been invested in things like bonds and securities. So they decided to put some of them into property. And this was one of the projects that they decided to do, actually the biggest they've done. So it is really an investment to make returns so that their life insurance members can earn better returns. When you do a headquarters building, other factors come in that perhaps override commercial terms, image and all that. So this was a commercial building. The client asked for, they wanted, first of all, an iconic building, that embodied strength. They're a financial company, so you want to be reliable. They wanted it to show strength and stability and to also be timeless. And that was a brief that was given to the architects. And they also made it clear that this building was going to be marketed to what we call grade A tenants, multinational grade A tenants, also local grade A, but were grade A. And because of that, various factors had to be considered. The location, I think we all know. We got here, so we know the location. And we won't go into too much into that, just to say that it's a 1.6 acre site that they acquired 20 or so years ago. And it housed one of those old houses. The surroundings, I think we also know the surroundings quite well. Upper Hill is becoming somewhat of a financial hub, and you find a lot of the insurance and banks, Equity Bank across the road, KCB, on the other side, UAP, and there are many. There are a lot of financial institutions and also other corporates, Coca-Cola, hotels coming up. So it was felt that of the properties they own, this was probably the most suited for an office development. Now, this is a 5-year engagement. And actually 5 years of my life, have been spent, not 24/7, but a big substantive part of that on this development. Design commenced in mid-2012. We had an excavation contract that commenced in April, ended in August of 2013. Just to answer, maybe not to answer, but to comment on the question that was asked about at what time do you engage, the excavation contractors. From our experience, we have found that it is better where you have extensive excavations, especially in this kind of areas, small sites with deep excavations. We have found that it is better to engage an excavation contractor on a separate contract. And there are two reasons for that. We have found that one, the excavation contractors have a lot of ability, and sometimes the main contractors just go to them and maybe even complicate some of the issues. So they have a lot of ability and to contract and do the work independently. And then secondly, as always happens, and we know in the industry it always happens, we always press for time. We always there's not enough time. This building had to be designed and be on site in a year. I would say we were struggling to get it on site in a year. So you actually do save time, because what you do is then you farm up all your ground, below ground design and specifications, and you can very quickly, working with the engineers, issue a document to excavation contractors. And as they are doing the excavations, you can then finalize on the design and the tender. So this excavation started in April. But we did not go to tender for the main contractor until about June of 2013. And construction started in September 2013. We had what we called a topping off ceremony. In tall structures, when you pour the last concrete normally, or the last significant structural works, you normally have a ceremony to top off the building. So we did have that, and the former governor was a chief guest in October 2015. So the structure actually took 2 years to build. And then the practical completion was achieved in November of 2017. So it took another 2 years to actually complete the finishes and the other parts of the project. And the last 1 year, we have now been on defects liability. We are now doing the final snagging. For this kind of buildings, defects liability periods are minimum a year. 6 months is a bit short. We normally would recommend a year. In terms of what the building is, 31,000 square meters of lettable space. Efficiency in terms of lettable versus gross plinth is at 83%. We have a silo, which is across there, 29,800 square meters with, it's 10 stories, 3 basements, and 2 top levels, housing a data center and an event space. And that the parking in this building is for 1,002 cars. The ratio is about 1 parking for 30 square meters or 33 square meters. In terms of height, the building is 137 square meters. That is up to the top of the concrete. And then we have a spire that is 62.2 square meters. Now, there are different ways of determining which is the highest building. I'll say a lot of, the jury is still out, but a lot of some of the standards talk about the tip of the building. So the tip of this building is at 200 meters, which makes it the second tallest building in Africa. Plot ratio, for the architects, 4.16. Previously, Upper Hill was plot ratio 3, so 4.16, ground coverage, 59%. The footprint of each floor, the biggest floor, which is the second floor, above this, is 1,200 square meters. and the top floor is 650 square meters. So the template of the building goes reducing as you go up. The building has three basic components: the tower, the atrium, which is on, just here where we entered, and that's the link between the two, and then the silo. When you actually park in the silo, where we have 3 lifts, just behind that wall there, you have to come, because of security, you have to come down to the ground floor, come in the lobby, and then go through what you all went through, security checks, and then go into the building. Just to touch on a bit on the type of foundations we have here. Basically, we have a raft. In tall buildings, because of issues of stability and various other considerations, invariably you end up having a basement because of services. Even if you don't cars, you'll have a basement. So because of that and the tall nature of the building, you normally will have fairly deep excavations. In this one, we're at about 11 meters excavation. What I've shown here is a raft, the tower raft, which at its deepest position, which is at the center, is a 5 meters, 5.2 meters, I think 5.2 meters at the center. So it's basically concrete, 5.2 meters high, heavily reinforced. Then it tails down to that area, which is 2.6 meters high, about the height of this, of just raw concrete. I think we had a class 40, if I'm not wrong. And then the smallest part in the tower, the raft is 1.6 meters. Because we had a fairly firm ground in this building, or in the ground conditions here, we did not have to do any piling. We know piling sometimes is required, as it has been outlined, and has been done for various buildings. It can be quite expensive. So, I mean, you had, was it 1 billion, less 10,000? Yeah, piling is expensive. We think, rafts, where you can do a raft, it's probably easier to do. The silo also has a raft, but a bit smaller in thickness than this. We did not encounter too many challenges in terms of the edges. They were fairly stable. In some of the areas, the rock here is quite high. I think we had the soil was 1.5 to 1.6 meters or 2 around there. So we do not have a lot of danger of the sides falling off. But in some areas, we had to hold back the soil and also do some, with some mesh, and also some concreting, some lean concrete. I think this is one of the items you mentioned. So we didn't have any serious problems with the foundations. What you see at the center there are the lift pits. And that's the lift lobby, actually, at the center. So that was the foundations and concrete. In terms of how the building design was arrived, as I said, the client wanted an iconic buildings. Some people say that iconic is simple. So, that principle was taken into account. And the Britam Tower is actually a very, very simple building, as I'll explain later. But the idea in this building was to have a building that tapers off to an apex, like Mount Kenya. So the inspiration was Mount Kenya. Strength and stability also, because of the mountain. It's rock, so strength and stable. We also felt that the design that was done would age gracefully and be attractive even in the future. So that was the inspiration. Those are some of the sketches that were done, initial sketches. Now, that in this diagram, it explains the simple design of the tower. It starts with the ground and the first up to the second floor being a perfect square of about 34 meters by 34 meters. So that the outer line there that you see there is a outline of the lower floors up to the second. And then what then happens for the floors after that, the corners are chamfered back. Each floor you chamfer, the corner, each corner is chamfered equally on all the 4 corners until by the time you reach the 30th floor, you have another perfect square that sits across the big square. So the footprint of, we went to the 30th floor. The footprint of the 30th floor is what you see in yellow. And through that, the building may appear, some people say that like the floors are moving, or that like it's irregular in shape in some areas, but actually it's a very, very simple concept. And because of that, it was the design, other than being a very tall building, the geometry of the design was actually quite simple. Doesn't look so because of the chamfers, but it's actually quite a simple plan. And then on that, we have the core. The core for the tower, the lower part of the tower up to the 20th floor is what you see in that line. It is basically a square, with that being the outline. And then the core of the 20th floor and above, because what happens is that these chamfers then start reaching the core, so you have to move it back. So the core is, an octagon from the 20th floor. And also what happens, up to the 20th floor, we have 8 lifts. But from the 21st up to the 30th, only 4 of the lifts go up, because you cannot, fit them within that smaller footprint, and you also don't need 8 lifts. The simple plan, we won't go too much into detail of the plans, but that's a plan, a typical plan design that we did for how the 20th floor could be fitted, and it showed that you can very comfortably fit 96 people using desks of 1.6 to 1.8 meters. If you go down to 1.4, you could even go up to 110 people per floor on each of the lower floors. And then it has a core, 4 lifts, 2 staircases. We didn't go into those, escape staircases, and the bathrooms are basically behind the core. And this core is a main structural element of the building. The walls are 400 thick concrete walls. These outer walls, they're all 400 thick, and we don't have columns there. All the columns are the peripheral, and they go back and support on that central core. When we go to the upper levels, 20 and above, the core wall thicknesses goes down to 300 millimeters. And again, we are using class 40 and 45 concrete. That is the top floor with the core at the center, and 2 lifts. And then this actually is a design of a fit-out that is currently being done for Britam, who are going to be sitting on the, occupying the 28th, 29th, and 30th. So this is going to be, one of their spaces. And on this, during design, because there were a lot of questions on how efficient is that floor, the design that was done, we could fit about 60 people. Britam, a bit generous because they have a lot of other, dinings and kitchens, so the people are less, but you can actually fit about 60 people on the top floor of the building. Overall, this building is designed to take 2,500, occupants, or thereabout. The tower is a concrete structure with a core. I think we've mentioned that. The facade has basically 2 skins. We have the curtain walling, on the inner skin, and then we have the terracotta baguettes. Terracotta baguettes are basically special screens made out of, the baguette itself is made out of a special clay that is burnt to a very high temperature. These are made in, in Germany, and terracotta actually is one of the materials out there that is becoming now a bit commonly used, not only for screens, but also for facade cladding. A lot of buildings in Europe and the US are cladded with terracotta panels. So this is from a company, I think most of us have heard about it, NBK, Hunter Douglas. They're the ones who supplied these baguettes that are supported on an aluminum frame. And the purpose of the baguettes is to screen the curtain walling because of ambient temperatures and those kind of things. So a design was done that optimized the type of glass that has been used here, which is high performance glass, and the baguettes working in sync. Things to do with even the spacing of that, which is 200 spacing, the baguettes. That was optimized based on the facade and the glass design that had been done, up to even the openings. As I said, we had the facade engineers in the UK. And for curtain wall buildings, where you have extensive curtain walls, would advise that you look at getting facade consultants. We've mentioned about, the ground floor is commercial, the rest are offices. We have 8 lifts, the fastest lifts, at least in the region. The 4 central lifts move at 6 meters per second, and the other 4 that reach the 20th move at 4 meters per second. And all this was done arising out of a study that looked at what is the maximum time when you have this building fully occupied that somebody should wait for a lift to come. And based on that, those lifts, the numbers and the speeds were specified. I think the target was to achieve a maximum waiting time of 30 seconds. If you're about 30 seconds, you're doing well. If you go to, 45 a minute, those times are becoming high. If you're below 30, you're doing very, very well. So we are about 30 with the design models that were done. Some images during construction. As I said, that took 4 years. There were a lot of challenges, especially on how to fix that curtain walling. What you see there are I-beams. Those are actually I-beams that are galvanized steel beams that are bolted on the edge of the facade concrete. As you can see, the beam, the columns are backset, and the beam is backset by about 1 meter, and the slab comes, out. And on those, the I-beams are bolted, and then the facade is the baguettes are fixed on the outer edge of those beams. And in between, I think it was in the other picture, there is a walkway. Another feature of construction, and this happens a lot with high-rise buildings, is how do you build them fast? How do you build the core? There are various technologies that are out there. In this particular one, the contractor engaged a company, I think from Europe, Central Europe, that provides a mechanically movable formwork that is called Docker formwork. So what that formwork, once they cast a floor, they'll just kind of loosen it, and then it would be mechanically raised to the next level. And because of that, those kind of technologies, that formwork, they were able to do, at the peak, they were able to cast 3 floors in a month. So they are doing 10, 11, 12 days per floor because of the speed of that kind of system. Another feature, structural, the engineers probably would explain this better, but because of the chamfering of the corners, there was a structural challenge because your columns cannot go up because the corners are moving back, and that necessitated design of angled columns, which you can see here at the corner. So they start angling, and then it reaches a point, as we were saying, and I think Engineer Goro observed that. It reaches a point where you cannot then span the slab between those 2 columns that are slanting because they are too far. So some other columns were introduced, running from those 2 main columns, and they met there, a floor above, and then another column, another column going up the building was, supported that. So I think those, not falling, but angled columns, those angled columns were probably perhaps the biggest design challenge from the engineers, but I think they were up to it. They have the latest technologies. One other thing that you always do with high-rise buildings is, peer review, especially of the structural work from other engineers. So, the engineers are working with another engineer to review what they are doing, because you really have to get it right and not have any catastrophe. And that is one of the wireframes that they did from one of their models, and you can see those columns that are springing up. And then these two, the columns at each corner, this corner we say 34, and the other corner, they actually go and meet at the top there, because now we have a perfect square at the top, and because of that, the last floor could not be a concrete, the roof, the top roof that we saw is steel because those columns ended at 30th floor. Then above that, we took 1 floor of steel. Other, now the curtain walling has, the baguettes have come up. The other big feature of this building, and what actually gave us probably the most headache, Iqbal is here, he'll probably agree with me, was how to put up that spire. Initially, the spire was designed to host wind turbines, and these wind turbines were supposed to generate electricity. That was the thinking, and if you look at, if you've seen some of the initial models of the building, I don't know about the model downstairs, probably. I think even the one downstairs, it has those turbines. And a supplier had been identified from the US, and the initial discussions held. But then what happened is that as we went further on with the design of that spire, and looking at these turbines, we started doing cost-benefit analysis. And it came out that the power the turbines were generating, I think was going to be less than 1% or thereabout of the building requirement. So it couldn't even power the lobbies alone. So because of that, the client said, okay, what is the payback time? And when that was done, it came back to, I think, something like 86 years. that in terms of how much energy will you save if you use that power to justify, for you to get back the money you spent in those turbines. So because of that, they were put aside, and that feature, was no longer there. Then what happened is that it was decided the spire cannot be left on its own. So some sculptural elements that tie around were designed in steel, and those were installed. The main challenge with this spire, it's 62 meters high. It's made of raw steel, steel plates, 3 millimeters thick, with a lot of bracings inside, and it's quite big. You can actually go in, as I told people, up to the top, 62 meters up. So the challenge was how to get it there. And remember, we are working with a crane, one crane that can only lift a certain weight. So it was decided it has to be built in pieces. So the pieces were, initially quarter of a circle, and 2 meters high. And even those were very, very heavy. I can't remember what they weighed, but I remember there were hundreds of kilos. So even to lift them was a challenge. So it was being lifted in pieces and then being put together at the top. And what you can see there is a scaffolding. The spire is 62 meters. This scaffolding that was built to enable the workers to work on it was 84 meters. It was close to 20 meters above the top of that spire. And you can imagine the workers had to go up every day in the morning when the weather was a bit chilly, or they would wait a bit, because it is actually very, very, very cold. They had to be warm jackets and all that. So that actually proved to be a huge challenge, but let me say eventually it was done, and it is a feature, and it was really now became just one of the elements to make the building iconic, if not the tallest buildings. Yeah, and then the other thing is how to protect it from weather. So we looked at galvanizing and various other ways of doing it. Eventually we arrived at a product called Zinga protective film, which has been applied to make sure it doesn't corrode. That is the same spire with a picture taken. Those are fabrication pictures of the steelwork in the yard. And that is the inside. This picture shows the inside of that spire. What you see, I think some of you who are brave enough probably went in. I'll admit I've never been to the top, but that's what you see, and you can actually walk up till the very, very top, and there are platforms on which you can walk out and stand and look at the city. Now at that almost 200 meter height. Yeah, actually what you see there is a first platform. This is the first platform. There's a second one, and there's another one at the very top. And there are doors from inside that you can then open and go onto that platform. Of course, they are not meant for people viewing. It's for maintenance. Yeah. Then other things, the atrium, I think I won't go too much into that. Glass, special glass at the top. A lot of the glass up there is toughened glass, fritted to reduce the light coming in. The parking silo, I think the biggest feature is that those screens that you see, these are basically precast concrete screens that have been precast in panels and then fixed between each floor. And basically, if you look at them, there are just three types of precast concrete panels. One formed an O, the other one formed an X, and the other one, you can't see it yet at the ends, it formed a V. And between those three, that was able to be, created, that kind of feature. Some of the other challenges were, when we started these developments, the restriction in Upper Hill was 15 floors. You could not build more than 15 floors. So there was a lot of lobbying, and this was being done, they were saying this because of issues of air traffic and all that. But after a lot of lobbying and discussions with KCAA, and including even the Air Force, a decision was made to lift the heights in Upper Hill. So today, those building other tall buildings that are about to overtake Britam, owe a lot of what they are doing to Britam, because it is during this lobby that the government decided to lift restrictions in Upper Hill to maximum of 350 meters. So that means you could do up to almost 80-something floors, almost 90 floors. So again, planning, normally a major issue with the tall buildings. Facade, I mentioned about the facade design. It's important when you do such a building to ensure it's a glass building. So the first thing you ask, glass in this region, does it work? Question that has been asked, studies have been done, models have been done, and the specifications have been done to show that it will work. We are all eagerly waiting for the building is not occupied, so until it's occupied, that's when we'll know. But the studies show that the ambient temperatures in the building are going to be okay, and you're going to. The challenge with glass is you have to balance two things. One is the amount of light coming in, what we call light transmission, and the second is the ability of the glass to keep out heat, or what sometimes is called as the G value. How much heat do you keep out? So you want to have the most light coming in, and yet keep out the most heat. And for high performance glasses, there are glasses that allow in light above, I think 64% of the light can come in, natural light can come in through the glass, but yet keep out 60% of the heat. And then what happens is as you push that glass to be very high performance, because even more higher performance glasses, what happens is that glass, you then start incurring the risk of breakage due to heat. So we were really treading fine lines and trying to see how can we get a glass that is not going to start breaking, because a lot of this glass keeps out heat by, it also becomes quite hot to keep out this heat, and it can break, it can just shatter. But we arrived at this particular glass from AGC Europe. I mentioned Terracotta was from NBK at Douglas. The aluminium sections and profiles are from a company called Hueck in Germany. And the galvanized walkways that you saw are from the UAE. There are a lot of safety issues. I won't go into all of them. Accessibility, sustainability. There are a lot of sustainability issues in this, provisions in this building. Initially, we were supposed to look at going for LEED or Green Star. That didn't happen. We later applied for what we call the EDGE rating, which I'm sure most of you know. You'll ask what are the reasons? A lot of things. One, recycling of grey water. All the water that is coming out of the wash and basins and all the water that will be in the kitchens goes to tanks in the basement below where we are, treated and recycled for use in the WCs and urinals. So this water is being recycled, and through that, a study was done to show that this building is going to save the water taken from the mains by close to 60%. We'll be taking 60% less water than if you do not have that system. Rainwater harvesting, again, we harvest quite a lot of water. There are tanks in the basement. I talked about the environmental studies that were done to ensure that the building has a lot of natural light. and sun shading of the facade, infrared systems, in the taps, urinals, all that is infrared. Those save water, the sanitary save water. LED lights, actually practically almost all the lights used in this building are LED, including the ones you saw in the lobbies. And all this is LED. The facade lighting has LED lights. Bamboo, you've seen extensive use of bamboo. Bamboo is an environmentally friendly material because it's easy to recycle, it grows fast, and that is why we chose bamboo for the lobby's cladding, other than maybe another type of timber. The other thing is the structure. The structure was designed very efficiently. The rating body, when they looked at the slabs, the T-slabs that you've seen, actually it was found that those were the most efficient way of designing that slab. So because of that, the building earned quite a bit of points. Those are some of the images, some of the studies that were done. Fire strategy, a lot of fire. The lobbies you are in are fire protected areas. They are what we call refuge areas. If there was a fire and you're in that lobby, you should be able to be there for well over an hour without any smoke or heat. The doors you see, the glass doors you see there to those lobbies are actually fire-rated glass. And that again is a very difficult thing to get. To have 1 hour fire-rated glass, is a fairly high spec. And we could have done timber fire doors, but we wanted some light into those lobbies. So there are a lot of fire standards over and above what we normally have here. The whole building is sprinklered, including the tenant areas. The tenants have to tap in onto the sprinkler system for their areas. All the common areas, there's a sprinkler system, and there are a lot of other fire, including evacuation. There are studies done on how this building should be evacuated. For high-rise buildings, it's something that you cannot avoid. We also have the electrical cables that service the critical installations, lifts, alarm systems. There are special cables that are called LSF cables, or low smoke and fumes emitting cables. What it means is that they take longer to burn, and that service, emergency lights and all those will be on for longer. And there are many other fire provisions. Facade lighting, I think most of you have seen it. That is also another feature. That is parking silo, and that changes quite a bit. And all this is programmable, and all this is on LED lights. And these are thousands of lights, but energy-wise, not very high consuming. Also the spire, at night, if you look at it, it has a lighting system. That's another, night shot of the various lighting systems. One other item that I just said I'll mention is high-rise buildings are costly buildings. And the cost is because, one, of the structure. When you're doing rafts with concrete of 5 meters, that is 5 meters deep of just concrete, and you have columns that are huge to support this building, you have cores, so that comes at a cost. The other thing that makes them very expensive is the services. You have to pump water to very high levels, the electrical installations. So these buildings are normally heavy on services. We did a comparison on some buildings we've been involved in. I'll not name them, but I'll just say that Tower A is 32. You can guess. I won't confirm or deny, but Tower A is 32 stories, and it's completed. Cost per square meter, 86,440 shillings. Tower B is 31 stories, also completed recently. Cost per square meter, 88,880. Tower C is 22 stories. So it's 10 stories lower than the other two. Recently completed also this year. Total cost per square meter, 63,554. Tower D is 18 stories, completed in 2015. 50,700 per square meter. and Tower E, 13 stories. Ongoing, cost per square meter, 46,326. All these are unfitted buildings. Only the common areas are fitted. Tenant areas, not fitted, cost not included. It would be interesting to see what the cost per square meter is going to be in buildings like the Pinnacle, which are 70 stories high, but I'm sure it will be above the 90,000, probably even above 100,000 shillings per square meter. I know people will say it's expensive, but you're building more on the same land, so you probably save on that. But those are that is a trend, and I don't think it changes anywhere. If you build a bungalow, the cost per square meter can be quite low. So I've also listed them there, and most of them I've talked about. The special things you'll see in high-rise buildings. And I was just thinking, what are the things that one can say? We talked about foundations, pay close attention. Structure, big. Stability, big. Storage, the amount of water storage in these buildings is enormous. We couldn't go into the basement of this building, but the tanks are huge, huge tanks. We say to 2,500 people, you want water that can last perhaps a week if you've no water coming in. So you can imagine how much storage you've got to put. So a lot of bulk storage, heavy in services, normally significant basements. For office buildings, heavy in parkings. The silo there, we tried what we could to make, we wish it was lower, because we were saying you have to drive 8-9 stories, but we had to get to 1,000 cars. So for office buildings, especially hotels are a bit less. Office buildings, in high-rise buildings, you'd be dealing with challenges of parking in this part of the world. Service floors, I mentioned to one of the group, you cannot take some of the services from the ground to the top. So you have to have an intermediate service floor. On this building is the 20th floor. Normally you have rooftop special features. Fire strategy is a very, very big thing in high-rise buildings. Fire strategy, something you must watch out for. In fact, I think, and I would recommend anything above 20, you must have a fire consultant looking at how the evacuation will happen and all that. Normally you have a lot of large project teams, documentation, cost per square meters, we've said they increase. Usable area. Usable area to the non-usable. This building is at 83%, usable to non-usable. And by usable, I mean lettable, what you let, what the tenant will pay for. If you calculate that, it is at 83%, because the tenants pay for the lobby and they also pay for the bathrooms. So it's at 83%. As you go higher, some studies we did of some buildings, 78 stories in the US, the efficiency is down to 66-65%, because the cores are becoming so big, and the services, the ducts, So as you go up, the higher you go up, the less the efficiency. And then safety during construction, big thing. We, are lucky enough, perhaps because of the measures that were put, we did not have any fatality on this building. We did have one worker who broke his leg, but that was the most serious accident we had on this side, notwithstanding the spire issues. That's a picture during 2013, the first site meeting with if you know Laxman Bai Construction, that is Mr. Laxman Bai himself, Mzee Laxman Bai. I think he's now about 83 or 84. But running a good company, and you probably will not pick me. I was twice my weight, but I'm somewhere there. Yeah, I was about 15 kilos more than I am today, but nothing to do with the building. And then that was another key moment when, just before the building was completed and the board of directors toured the building, including the chairman, Francis Mudaura. That is Francis Mudaura, Peter Munga, Benson Oeregi, the project manager, Jacqueline, that is me, and that was the board of Britam. It's a good moment at the rooftop. I'll just go by the order I've written them. Fees, how much are you paid? the percentages are probably less because the clients say the volume is more. So, clients negotiate, and because of volumes, yeah. You are beaten down. But let me say, yeah, there's no, yeah, well, okay. There's no borax in the room, I'm told. But let me say it is, a lot of time, and 5 years is quite a bit. In terms of the shapes of the two buildings, I think the parking silo, as I said, had to be because of the way you park and the way you circulate. It was going to be very inefficient, and probably would have had to go higher if we went with with a shape that had reducing corners. So because of the efficiency of the parking and the numbers and the push for numbers, I wish you could have designed it to have the same shape, but because of the push for numbers and to limit the height, we went with that particular shape. Facade lighting costs, I'll be forthright with that, 50 million shillings. As to payback, it's a soft issue, it's a marketing issue, it's an image issue, difficult to quantify. But it is hoped that it will pay back that money. Overall, on the whole project budget is 1%. The facade lighting is 1%, so you can decide whether it's worth it or not. Lobby and fire, yes. The lobby, if there's a fire in the lobby, then there's a bit of trouble. But one thing about that lobby is for fire to move between floors is not easy. So it would be constrained within that floor. And then you also make sure there is as little fire load in that lobby as possible. No tenants are allowed to store, some of them were saying there are some small rooms there. Small, can we store stationery? Can we do this? And the tenant manual stipulates on what you can use it for. So you try and design, there are sprinkler systems. There are some of those are fire doors. The door you see going to the bathrooms on the right, you go out, that's also a fire rated door. So actually that fire would have to start just within that space of the lift itself, and you try and minimize that if that happens. We also have two of the lifts in this building are fire lifts. One of the 80 is a fire lift, and one of the 3 in the silo is a fire lift, fireman's lift. Extensive, very, very costly. That one lift is probably worth 3 of the rest because of the special installations in it. And I think you need those for buildings that high-rise buildings. The other one was a fiber and internet. This building has a fiber optic, backbone cable. And on each floor, we didn't open the ducts, but on each floor, there are panels. These cables terminate on a panel where the tenant, once they choose whichever, service provider, the service provider will just come and connect in the basement, in the communication room, just plug in. And from their floor, on that panel that is in one of these ducts, once they plug in, they'll be on fiber. So there is provision for that, and the client has also been engaging various suppliers in order to provide wireless internet in the building. So I think those are the questions that were asked. Just wind load. Engineer Machocho, you could just mention just 1 or 2 things about the wind load.
Good evening. I am Edward Mashosho. I'm a civil structural engineer. But on this building, I was mainly on the structure. I wasn't alone. I had a full team. And the main item that we considered when we started off the building was that there was a geotechnical that had been done earlier, which had considered 3 boreholes. When we came in, we recommended that we needed to have 2 more boreholes that went deeper, and that gives you comfort that what you saw here was already considered right from start. Now, regarding the earthquake design, that was fully considered, and we used the 2 codes mainly, the UBC that's American. We also had the Kenyan code. We know it's old, it's 1970s. But we considered both, and we used the more onerous, and the UBC required that I thought you saw the foundation. That cross-section of 2.65 deep foundation was actually coming out of the design. And out of that, that's just concrete you are seeing. If you saw the reinforcement that was there, I think you would have, it was quite an amazement because we had 4 layers of T32s. And the walls were 400 thick, and they also had 4 layers of T32 at the bottom. So that means that the earthquake was fully considered, and that's the whole of the core. And that core was all around the 4 edges and also in the middle of the lift. So all that took care of the earthquake. Regarding the spire, we also had the design of the spire, and we just don't use one software. It means we used several software. We had DTabs, we had robot, we also had RAM that we used to design to ensure that everything is taken care of. We didn't take the wind tunnel test, because that's a question I know someone would ask. The main reason is that the building being 30-story is really, according to design, is not that tall. Because we are able to even deal with 100 stories, and once you get to that point, you really need to undertake the wind tunnel test. So the spire itself is really mounted on a spherical concrete wall that was 300 meters deep to connect with the main core. That's the one that goes around the lift. And then we had bolts that were going inside by 1.2 meters. And those were 32 dia bolts, a total of 60 number. And on the connection with at the bottom, it had double flange plate. Those were 32 meter thick. No, sorry, 25 millimeter thick, double of them, to ensure that the bolts have really connected. And what you're seeing, the shell, the outer cover, the spire would still work without that. It was just a cover. So the main structure is inside, what you saw as you looked from inside. So what we have here is a stable, what we would think of is nothing can really shake it. Thank you.
Thank you very much, Engineer Michael. My duty this evening is, I don't want to dilute what you've learned today, so I just want to give you a vote of thanks. As is mentioned, my name is Engineer Grace Kagondo. I was the former chair of the Engineers Chapter, and now I'm in the council, and I think we're very much working together on this presentation. So I want to start by giving a vote of thanks to Tile and Carpet, who was represented here by Ashpal Sabawal. He's already left. So can we just give him a very big round of applause? Yeah, because they were the main sponsors of this event. And I think it's good to have some few takeaways from Tile and Carpet Center. They have factories in Nairobi and Bahrain. And they have also 8 profiles of roofing material in 18 colors. And I think I checked the colors, and I like espresso, and I also like pepper. I think you check them out. They look really good. And of course, the best part of it is that they have 50 years warranty. So I think those are products that we can actually identify with. They are products that we can use to get quality construction. The second team I would like to appreciate this evening is Britam. I think very, very special thanks to Britam for allowing us to share the experience in coming up with this wonderful building. You've just seen it. It's just amazing, isn't it? Yeah, so I think for investing in such a building and for allowing us to be part of it and for sharing the knowledge that came out of it, we thank you very, very much, Britam. I don't know whether they're here. Anyone from Britam? Yes, Asante Sana. What's his name again? Martin. Asante Sana, Martin. That was excellent. We are very, very appreciative. Thirdly, I want to thank the presenters. We have learned so much from you. Patrick Wanjohi, Asante Sana. In fact, as you were explaining, I was thinking that I think when I become an engineer, I would like to be able to speak like you. I mean, you really simplified everything, and I think anyone could understand what you're talking about, the excavations. I also want to appreciate Charles Ndung'u. Where has he moved to? Yeah, hi. Yeah, thank you so much, Charles Ndung'u from Triad. I think I want to especially appreciate that you are speaking on behalf of a very big team. When I saw the list of the consultants who are involved, I can only say thank you very much. The engineers, you're speaking for engineers, you're speaking for the architect, for the facade designers. This is the first time I'm hearing of facade designers. I think we need to introduce such a course at the university, isn't it? It looks like it's a serious thing. Yeah, so, and also for the fire specialists and the whole list of specialists, thank you very much. That was so excellent. And for you, I think the word that came to my mind is simplicity is the ultimate complexity. Yeah, when I see this building. Yes? I want to appreciate the co-host, AK Engineers Chapter, represented here. I think I'll start by, in absentia, the current chapter chairperson, Engineer Ben Nyawade. Apologies from him. He wasn't able to attend this evening, but he told me, please come on my behalf. And I told him I definitely will come. And of course, I want to appreciate Engineer Michael Nderito, our MC for the day, and a wonderful host. I think, asante sana, engineer. I didn't know you make such an excellent MC. Why do we always pay MCs for our functions? Now we know. Okay, asante sana, Michael. And of course, last but not least, I want to appreciate the guests, all of you who have made this possible. As was mentioned by the president, Emma Miloyo. By the way, thank you very much again, Emma, for being with this group. I think we were definitely oversubscribed. Yeah, so I think that shows that we have a lot of interest in learning about a real life experience, practical example, and we should be having more of such events in future. So I want to say this is the only way we can have a very vibrant association when people turn out like this. And of course, we expand our knowledge and also we network in the middle of learning the knowledge. So thank you very much for turning up and for making this event a very big success. Thank you very much, everyone. Emma, do you want to say something? Thank you to Lina. Of course. Thank you to the paparazzi. And the secretariat. Yeah, I don't know. I know Terracotta Moon. I'm not sure I know that. Build design. Terracotta Moon, and of course, where is Lina? The secretariat represented here by Lina and Jacob. Yeah, asanteni sana. That was a great evening, and thank you very much. Have a great evening.